Okay, so this is the code we had where we used for loops to do Knightrider. So we had 4 loops here. And just to show you what the code looks like, if I upload and run, we start at pin 7, we go across to 13, and then back to 7, and the program just continues. So I'd like to show you one other thing, and that is maybe let's have this code speed up over time. And what we could do is we can either have it speed up and then just stop speeding up at some point, so some kind of limit, or we could have it speed up and then slow down and speed up and slow down. So let's start with the first one. Let's just have it speed up the flashing back and forth and stop at some kind of a limit. So how do we do that? Well, let's take a look at the code. When we pause, we're pausing for half a second in 2 different spots. And what we really want to do is we want to change that amount that we delay, and therefore we need a variable for it. Now, where do we make the variable? So if I make a variable inside this loop, then we call that a local variable. It only exists within this loop, which could be fine. The problem with doing that, so if we make an int variable called speed, if I initialize it to be 500, then the problem with doing that is every time I go across and back, it'll reinitialize and remake this variable of 500. And so that's one of the problems with local variables, is if I want them to kind of keep going up or going down, we can't have a local variable, but we need to make it what we call a global variable. So in order to make it a global variable, we move that variable declaration above the setup. So we can put it here. Now what we want to do actually is this should be fine. I just want to test this, make sure it's okay. Yeah, so we have now one speed variable called 500. We do our setup when we give the Arduino power, and then we go into our loop from there on. Now the speed is set to 500, so I can use this speed variable wherever. If I use it in my delay, all is well. And the code, if I upload and run it, it should not have changed at all. Alright. So now what we can do though is, because this is a global variable, we can actually change the speed variable in this loop, and the changes will stick, because this is only initialized once when the code is compiled and ran. So what would I like to do? Well, maybe after I do one complete go round of these, I would like to decrease speed. So we can say something like speed equals speed minus. Now we want to make it noticeable, so why don't I take away 20 milliseconds? And we'll just make a comment like increase the speed that the LEDs are moving. Okay, also known as if we decrease the delay, right? If we decrease the delay, then it'll look like the LEDs are moving faster back and forth. So let's let this run a couple times. Every time it does one complete pass from 7 to 13 and back to 7, we'll see the speed increase because the delay has been decreased. Okay, so we're at 500, still at 500, and then now we're at 480, a pause of 480. Okay, so that we can see this more obvious, let's make this a speed decrease of 100. Okay, so now it's going to be really obvious, because every time I do one complete cycle from 7 to 13, it's going to now go to 400 milliseconds, then 300, then 200, and when we get to about 100, it's going to go to 0, and they're all just going to look like they're on. Okay, So I don't think it knows how to simulate this. I'm pretty sure that if you did this actually with a physical Arduino, it would just look like they were all on. But okay, so there we have it. That's how you can kind of increase the speed using a variable. But one thing that we like to do a lot of times is we like to put a limiter on this, because what's happened here is speed was 500, then it was 400, then 300, 200, 100, it was 0, and then it actually starts going it starts going into the negatives. So we're delaying 0, which is nothing, then we're delaying a negative amount, which I'm sure probably just gets converted to 0. It's probably just ignored in the microprocessor. And then we just keep going, you know, and after this runs for a while, speed probably goes into huge negative numbers. So if we want to limit this delay, so say we want to start it at 500, but we want it to stop. We never want it to go like the delay to get less than 100. We can say something like this: if the speed is less than 100, then all we will do is make the speed 100. Okay, so this is a good thing if we ever want to kind of cap the speeds at something. So at some point the speed's going to be 100. When we execute this, it's going to say 100 minus 100, it'll go to 0. If the speed is less than 100, well, it's 0, so it is. It'll just assign it to be 100. And so now we should see it'll speed up, but it will never get faster than 100 millisecond pause. Okay, so it's 500 right now. So now it's 400 delay. Now it's a 300 millisecond delay with a 200 millisecond delay, a 100 millisecond delay, and then it just stays there. Alright, so that's about it. That's all I really wanted to show you on this tutorial. Happy coding.